Hi everybody, let me go ahead and just get started on our lesson 2.3 in Amplify. So you are in chapter 2, lesson 3, and you're going to go ahead and start with a warm-up activity number 1. And this warm-up activity is asking you to read about Marta, who observed a flowing stream in a sandy area. So she developed a claim that water flowing over sand will create a curved and winding channel. So there's a couple questions there that I want you to answer. Remember, when we do our warm-up, there's no right or wrong answer. The warm-ups are really just to get you started to think. And in science, there's no bad idea. So go ahead and answer those questions associated with the warm-up. Make sure that you hit hand in and pause this video. When you're ready to move on, then do so. Okay, so you are finished with the warm-up. You've gone ahead and handed that in. We've got a key concept. So you're going to pause this video after I explain the key concept. And you're going to write this in Good Notes. So remember, you're going to go into your Good Notes. You're going to go into the geometry, I always say geometry. Go into the Geology on Mars folder. And inside that folder, you have a key concept graphic organizer. You should have 3 key concepts already. Key concept number 4 will go in that little slot. Let me explain it to you really quickly, and then you can pause the video and go ahead and write this in. So key concept number 4 says landforms can provide evidence about the past because they remain after the geologic processes that formed them stop happening. So what we saw yesterday in the stream table experiment that we did was that after the water stopped flowing, the landforms remained. Even after we waited a couple minutes and let the water drain out, those landforms didn't go anywhere. So when you are trying to figure out what happened, we can look at landforms and know that that can be used as evidence about the past. So go ahead and pause this video and write that into your key concepts graphic organizer. Okay, so we're going to go ahead and go to activity number 2, and this is where we're going to test an idea with the flowing water model. We've got the water model, and I'm going to have another video showing you the demonstration that we do. But we've got our chapter 2 question that, remember, we decided in chapter 1, it wasn't enough for us just to have photographs of landforms on Earth that were formed by flowing water and flowing lava. And it wasn't enough that we've got that satellite image of the channel on Mars. A picture is just not enough evidence for us to be able to say that channel was formed by water or it was formed by lava. So we need more information. In our chapter 2 question, how can we gather more evidence about whether lava or water formed on the channel on Mars? We have decided to focus our energy on using models. And so we've got our physical model, which is the sand trays here. We call them stream tables. And we used a flowing water model to get more evidence about what formed the channel on Mars. And we observed that once that water stopped flowing, the landform that was formed remains. So we're going to kind of continue with that idea. In class, I asked the kids to answer the homework question, first one, second one, and then we talked a little bit about the third one. But the first question was, how is flowing water model similar to flowing water on Earth? And that's important for us to remember that models are really helpful to us because they can kind of mimic what we see on Earth. So the model was similar in that it used water, and the water had force, and the water picked up the grains of sand and deposited them down. Remember, that's called deposition. And deposited them down. And in the process of all of that, it created this channel. So that's how it's similar. Now, question number 2, how is the flowing water model different than flowing water on Earth? Well, it's different because it didn't take very long for that to happen, number 1. It's also different because it's sand. And on Earth, lots of times we've got like solid rock. that takes a long time to erode and for that water to change it. So that's how the model is different. Remember, there's always limitations with models because they're not the real thing. We've got another key concept, so hopefully you didn't get all the way out of Good Notes. Come on back and we'll do that. Let me go ahead and explain number 5, and then I'll pause and let you write it in. So key concept number 5 reminds us that models do have their limitations. It says models represent the natural processes being investigated in important ways, but they are not exactly the same. And it's important to remember that they do have their limitations. So go ahead and write that into your key concept number 5 space in your graphic organizer. So that's the last key concept we're going to have. I'm hoping that you guys are spending 10 minutes every single day reviewing those key concepts. You should be writing those down in your Quizlet, reviewing those. Remember, this is information that you're going to be able to use when you write your scientific argument, because this explains why the evidence we use supports the claim that you make. This is our reasoning. So again, really, really important that you're spending time remembering each of these key concepts. So for today, we're going to use the flowing water model again. And what we did in class is I asked the kids, what are some ideas that you would have for us to mimic what's going on Earth? How can we change our model in order to test it out to see if something maybe setting it up a little bit differently would make a difference in what we saw as far as the landform. And one of the things that we did, well, let me tell you this. Go ahead and go into Schoology, and you're going to see a PDF called Lab Report Number 2. Copy that into your Geology on Mars folder, and then I'll wait. You guys come on back, start the video again, and I'll keep talking. Okay, let me explain what's going on here. So the stream tables are slanted just like this to show how water flows downhill in the natural world. In the lab that we're doing today, we're going to use 2 stream tables in a model because we want to test an idea about water flowing downhill. So we're going to keep one of the tables exactly the way that it was yesterday. So in other words, it's elevated slightly. And then we're going to change another one. And let me ask you before I show you the next slide, how would you change it if we wanted to see if the steepness of the hill affected the formation of the landform? What could we do differently to this setup? If you think maybe the second tray should be a little bit steeper, that's a great idea. And in fact, that's what we did, and you'll see that in the video. So when water flows downhill, the steepness of the hill might affect the channel formed by the water. And as we were talking about this in class, the kids thought, and I would like you to think about this for a second before I talk about what they said. So as we were talking about it, the kids thought if the steepness of the hill was greater, then the channel might be deeper, and also the channel might be a little bit wider because there's more force associated with the water. So we went ahead and recorded on number 1, and go ahead and pause the video and write your recording. The scientific ideas that we are testing is the steepness of the hill. Okay? So we brainstormed, we came up that we're going to go ahead and prop that table up a little bit higher for the second one, and you'll see that when you see the video. And so for number 2, you're going to record how we'll set up the 2 stream tables differently. So describe, you might want to wait until you actually see the video, and then you can kind of describe it a little bit better. But one of the stream tables is going to be a little bit steeper. I'm going to have more books stacked on top of each other so that that table is a little bit, or the tray is a little steeper. When you see that, go ahead and record that in that number 2. And then we went ahead and tested that. I'm going to let you see that. I wanted you to identify, and I'll say this in the video, while we're observing the water flow, I want you, just like yesterday, you're going to write down your observations. What did you see happen when the water was actually flowing? And you'll write that in number 3. And you can use that word bank. Okay? And then once the water stopped flowing, I want you on the second page, it asks, did it support the idea that we were testing? In other words, we have our hypothesis that we think if we made it steeper, then the channel would get deeper or it would get wider. And so again, I'm sorry to keep saying this, but you're going to have to watch the video to see what happens. I don't want to tell you what happens here. So just make sure that you're filling out the worksheet. Follow the directions on the worksheet. So you have tested flowing water. Now the other claim, as far as what made that channel on Mars, the other claim is that flowing lava made that channel on Mars. And so I would love to show you what that would look like. So remember, claim number 1 said flowing water formed the channel on Mars. Claim number 2 said flowing lava formed the channel on Mars. We need to make a model so that we could see what might happen if lava was flowing on Mars. Would it make a channel like that? So we're going to watch a video of a new model to get evidence about whether flowing lava could have formed that channel on Mars. The flowing water model used real water to represent water in the natural world, but actual lava cannot be used to represent flowing lava for very obvious reasons. The flowing lava model uses wax to represent lava. This is a great material to use instead of lava because wax and lava are both thick and they're both melted, and we can use wax to learn about the landforms that flowing lava might form in the natural world. So then in a moment, you're going to carefully observe a model in a video. And I'm going to use the video here from Amplify, so you'll see it on this video. And then you're going to record your observations, and I believe that's on page 3 in your packet. And in class, we talked about the ideas with a partner. If you have a parent or a sibling or somebody at home, it would be fun for you to talk with them about that, okay? So, yeah, I think in that third page, on the third page of the packet, you're going to record your observations about the landforms that remain after the wax has stopped flowing. All right, so here's the video. Make sure that's turned up.
This is a tilted tub of sand that represents a sloped hill. In a moment, hot wax will pour from the blue water bottle to model a lava flow. Wax can substitute for lava because both are thick melted substances that harden as they cool. By observing this model, we can learn about a landform flowing lava might make. While the model is running, try to make careful observations.
So there's a hole on the bottom of this
Now,
bottle.
the melted wax is flowing down the slope. The model takes about 5 minutes to run, so we're going to speed up the video footage.
Do you see that fan that's happening at the bottom? There's no hole in this one, so the wax isn't being poured out, so it's pooling down at the bottom. But it's very similar to what we saw with the water.
The model is now finished, and we can see that the wax created a channel. Let's watch it again to understand how the wax made the channel. As the hot wax flows down the slope, some of the wax on the edges and the bottom cools and becomes solid. This process builds the channel. The wax that does not harden pours through the channel and pools at the bottom in a fan shape. Eventually, all of the melted wax clears out of the channel, and we can observe the structure very clearly. We can see the structure has two walls that form a channel in between them. By running this flowing lava model, we can now see how it's possible for flowing lava to make a channel landform.
Are you surprised? The first time I saw this video, I was shocked. I thought, well, lava is going to sit on top of the land. And it was shocking to me to realize that lava can actually form a channel. So let's talk about using the evidence to decide whether flowing lava supports the flowing lava claim, and it actually does. We can use that video as evidence that flowing lava really does form a channel. So we've come to find out that flowing water and flowing lava can form a channel. Okay, so we've been gathering evidence about what formed the channel on Mars. By now, you probably have an idea of which claim you think is more convincing. In the next few lessons, you're going to consider new evidence from NASA about which geologic process formed the channel on Mars. So the last page in your packet is homework. And this, I just want you to consider how the flowing lava model is similar and how it is different than the geologic process of flowing lava on Earth. If you are having a hard time, go back and listen to the video, because the person in the video was talking and explained why they used why they used wax instead of lava. And then think about the differences and what are the limitations of this, okay? You're going to finish that last page. It's on the back page for your homework. And that is it, my friends. I'm going to stop this video, and then I'm going to have you watch the second video in which we are we're doing the different water experiment. Okay? Let me know if you have any questions.